Imagine a country literally floating on oil. Its proven reserves are greater than those of Saudi Arabia. This would be enough to supply the entire world alone for decades. Now imagine that in this very country, people are lining up for gasoline for days. Our plants are shutting down due to fuel shortages, and millions of citizens are fleeing poverty. How could an oil paradise turn into such a trap? Everyone is used to blaming only politics and sanctions, but that's only part of the truth. The real reason for this paradox is hidden deep underground, and it has to do with the very nature of this black gold, which turned out to be completely different from what we imagine. To understand the scale of this anomaly, let's just use some numbers. Venezuela's proven oil reserves are over 300 billion barrels. So you understand what that means? This is more than Saudi Arabia, the global oil giant, with approximately $267 billion with $10 billion. This resource would be enough to cover the entire global oil demand for almost 10 years alone. It would seem that a country with such wealth under its feet is destined for prosperity. But the reality is a cruel mockery. Hyperinflation wipes out savings literally overnight. Millions of refugees have fled the country in search of food and work. And the most absurd symbol of this collapse are the days-long, sometimes weeks-long queues for gasoline in a country literally swimming on oil. Power plants are shut down because there is no fuel for them, Arne. Agriculture is paralyzed because farmers have no diesel for their tractors. And at this point, most viewers already have an answer. Bad government, corruption, an ineffective economic model, and of course, harsh international sanctions are to blame for everything. And all of this is true. These factors have undoubtedly played a hugely destructive role. They became the hurricane that swept away the country's economy. But that's not the whole truth. These political and economic failures are merely a catalyst, an accelerator of disaster. They explain why the management system failed, but they don't explain why the oil industry itself, the heart of the country, began to physically fail. It's like blaming only the engineer for a train wreck, ignoring the fact that the tracks beneath him had rusted and crumbled. Even with the most catastrophic management, 300 billion barrels of oil is a continent-sized safety net, okay. It's an asset that could have been sold, albeit at a discount, to buy food, medicine, and sustain life in the country. Any other country with similar problems but such reserves could have held out much longer, but Venezuela couldn't. Why didn't this safety net work? What's so special about Venezuelan oil that its colossal volumes didn't save the country, but rather seemed to worsen its decline, turning from a blessing into a curse? The problem wasn't that the oil couldn't be sold properly. The problem was that at some point it became physically impossible to extract and transport in the same quantities. To understand how this happened, we need to move beyond economics and politics to geology and chemistry. It's there in the very nature of this black gold that the key to solving the Venezuelan paradox lies. The key lies in a simple yet subtle fact. Not all oil is created equal. In most people's minds, black gold is a uniform black liquid, but in reality, it's a product as varied as wine or cheese or cheese. There are light, flowing, and expensive varieties, and there are heavy, viscous, and cheap ones. To understand the difference, imagine two substances. One is warm olive oil liquid and flowing, easily poured from one container to another. The other is coal tar or bitumen, the kind used to cover roofs. A thick, viscous, almost solid mass. The vast majority of Medica, of Venezuela's 300 billion barrels of wealth, isn't olive oil, it's tarraca. This is super heavy crude found primarily in a geological formation known as the oil belt. And when we say super heavy, it's not just a pretty adjective, it's a physical characteristic that changes everything. At normal surface temperatures, this oil doesn't flow at all. Its consistency is so dense that it's more like asphalt. If you scoop it up with a bucket and turn it over, it won't pour out. It will very slowly slide off in a lump. The oil industry uses a special scale called API degrees to measure density. The higher the number, the lighter and more fluid the oil. Benchmark grades like Brenda or American WTI have a density of around 40 degrees Celsius, while water has a density of 10 degrees Celsius. And the extra heavy oil from the Orinoco belt often has an API gravity below 10, sometimes 8 or even 7. This means it's denser than water, DT heavy. It sinks in water like a rock. It's no longer just oil. It's a complex mixture of giant hydrocarbon molecules with enormous sulfur and heavy metal content. Essentially, it's natural bitumen. And here we come to the main physical barrier against which the Venezuelan economy has crashed. Imagine owning a giant underground lake, but it's filled not with liquid, but with something like cold honey or resin. How would you extract it? And even if you figured out a way to pump it to the surface, what next? How would you get this asphalt to Frecola through pipes hundreds of kilometers and and export terminals at ports? You can't just pump it. It's too viscous. It would create colossal resistance and simply clog the pipeline. Here's the cursed wealth in all its glory. Enormous reserves of energy that are impossible to transport. A resource that exists, yet somehow doesn't exist. It's like having a gold bar the size of a house, but lacking the tools to chip away at it. And yet, for decades, Venezuela was one of the world's largest exporters. Engineers found a way to make this asphalt flow. They devised an elegant, yet as it turned out, diabolically risky trick to cheat the laws of physics. It was this trick that transformed useless bitumen into a global commodity. And it was this trick that ultimately rendered the country's entire oil system incredibly fragile and held hostage to a single component without which this entire gigantic machine of extraction and export simply grinds to a halt. So how did the engineers make this asphalt flow? The solution was simultaneously brilliant in its simplicity and terrifyingly risky from a long-term strategy perspective. If your sauce is too thick, you add water or broth. If honey crystallizes, you dilute it a little to make it flowable again. Venezuelan engineers did the same thing, only on an industrial scale, with millions of barrels of oil. They decided not to fight the viscosity, but to dilute it, mixing this natural bitumen with something lighter and more fluid. This magic ingredient in the industry is called a diluent. Moment. The diluent is either very light crude oil of other grades or special petroleum products such as naphtha, essentially a product of the primary distillation of crude oil similar to very light gasoline. And here comes the main absurdity. The economic oxymoron on which Venezuela's entire power rested. To sell its oil, the country had to constantly buy from others. Imagine this logistical carousel. Giant tankers from other countries arrive at Venezuelan ports, but they don't pick up oil. On the contrary, they bring it at very light diluent. This imported product is then pumped through a special pipeline network hundreds of kilometers inland to the Poyasanoco fields. Por the Asahasibol, the asphalt is mined. Where mixing takes place in specialized upgrading plants. The super heavy bitumen, barely pumpable from the ground, is mixed with a light imported thinner in a ratio of approximately 2:1 or 30. The result is a new synthetic oil mixture. It is still heavy and sulfurous by global standards, but now it is fluid enough to be pumped through pipelines. Only then is the resulting mixture, which can now be sold, for example, under the famous brand Mary 16, sent through another pipeline system back to the coast to the same ports, where it is finally loaded onto other tankers and shipped for export around the world. The circle is complete. To export 2 or 3 barrels of domestic oil, it was first necessary to import 1 barrel of foreign oil. The country's entire economy, its entire export potential, was held hostage by this continuous cycle of import-export blending. It was a brilliant engineering scheme, but from economic and national security perspective, it was a ticking time bomb. The system was expensive and vulnerable. Every barrel of exported oil was burdened with the cost of imported diluent. But as long as global oil prices were high and supplier relationships were stable, it worked. Venezuela earned enough to cover the cost of imported diluent and reap huge profits. This dependence was the Achilles heel of its entire oil industry. But for decades, it was overlooked. It seemed simply a technicality of business, a cost of production. Then the political situation changed dramatically, and Venezuela's main trading partner, which supplied the lion's share of these vital diluents, decided to strike. And it struck not at the banks or the politicians. It struck right here, at the very heart of this fragile technological chain, turning off the tap on which everything depended. This Achilles pita, this dependence on imported diluent, was an open secret in the oil industry, mole industry. For decades, it was viewed as an annoying but solvable technical problem. But in geopolitics, any technical vulnerability is a potential weapon. And in 2017, and then with renewed devastating force in 2019, this weapon was fired. For many years, the United States had been the main supplier of those very diluents to Venezuela. American refineries on the Gulf Coast produced light petroleum products ideal for this purpose and were located in convenient logistical proximity. It was the United States that supplied the very soup in which Venezuela made its asphalt. And it was the United States that these strike at the very heart of this system. The sanctions imposed by Washington were not simply financial. They were a targeted surgical strike on the supply chain, and American companies were expressly prohibited from supplying diluents to Venezuela. The tap on which the country's entire oil industry depended was turned off. And at that moment, an engineering vulnerability turned into a full-scale man-made disaster. Imagine the chain reaction. Tankers carrying diluent stop arriving at ports. Mixing plants deep in the country run out of the vital ingredient, but production of extra heavy crude continues under inertia. This thick, viscous bitumen continues to be pumped from underground, but what to do with it? There's nothing left to mix it with. First, temporary storage facilities at the fields overflow. Then this thick, unrefined mass begins to fill pipelines designed for the already flowing mixture, but without diluent, it won't flow. Under the pressure of the pumps, it slowly creeps forward, cools, and its viscosity increases exponentially. The pipelines, the arteries of the national economy, begin to choke. Hundreds of kilometers of steel pipes, worth billions of dollars, are visibly turning into monolithic rods filled with hardened asphalt. The system is physically breaking down. Production is forced to be urgently shut down. Wells are mothballed one after another. The Orinoco oil belt, the source of colossal wealth, is dying down. But the disaster doesn't end there. It spreads to the next stage, refining oil. Venezuelan refineries, like the entire system, were not designed to handle pure bitumen. Trying to process this asphalt directly is like pouring sand into a Formula One car's engine. Extremely high sulfur and heavy metal content corrodes equipment, and huge hydrocarbon molecules clog heat catalytic converters. Refineries already suffering from underfunding and a shortage of spare parts begin to fail one after another. And now this absurdity has reached its climax. A country sitting on the walls of just oil reserves is unable to produce enough gasoline, even for its oil needs. This is why lines at gas stations stretch for days. Not because there's no oil, but because it can't be delivered or processed. A geological curse that engineers had contained for decades with technology and imported supplies was unleashed by a single political decision. Unsaleable wealth turned into poison, beginning to destroy the country from within. The trap snapped shut. Venezuela was left alone with its frozen, useless treasure. But the story didn't end there. In a desperate struggle for survival, the system began searching for workarounds. And these searches led to even stranger alliances and riskier deals that changed the rules of the game in the global shadow oil market. So we have assembled all the pieces of this puzzle. The unique geology that gave birth to super heavy oil, almost like asphalt. A sophisticated technology that learned to dilute this asphalt, but in the process made the entire country hostage to an imported component. And finally, a ruthless policy that struck precisely at this single vulnerable point. Geology, technology, and politics converged to create the perfect storm that slammed Venezuela. But the story doesn't end with the moment of collapse. A desperate struggle for survival follows. When the main supplier of diluents from the US turned off the tap, the system panicked and began searching for and found it in fellow pariah states under international sanctions. The main new partner was Iran. A new, even more absurd and complex logistical chain emerged. Iranian tankers, often turning off their transponders and traveling in shadow fleets to avoid detection, began crossing half the world. They were carrying that very life-saving diluent to Venezuela. In exchange, they took the Venezuelan super-heavy crude oil that Iran, with its sophisticated refineries, could process. This was a deal not so much for profit as for survival. Venezuela was given the opportunity to at least export something, and Iran was able to sell its surplus petroleum products in defiance of sanctions. A strange symbiosis developed between two paralyzed economies desperately trying to keep each other afloat. But while these risky deals were being negotiated at the highest levels, on the ground in Venezuela itself, physical disintegration continued. A shortage of diluents and the shutdown of modern refineries led to an environmental catastrophe. Oil, which could neither be processed nor exported, began to accumulate in temporary storage facilities, which quickly overflowed. Numerous spills ensued. A mixture of crude oil, salt water, and mud began seeping into the soil, polluting rivers and lakes. The famous Lake Maracaibo, once the cradle of the country's oil industry, was covered in gigantic oil slicks. At the same time, the infrastructure itself was deteriorating. Pipelines clogged with frozen bitumen are more than just a temporary blockage, they represent multi-billion-dollar damage. Clearing them requires specialized technology, a huge amount of chemicals, and time, while often it's easier and cheaper to cut them out and rebuild them. Out. Refineries idle or running on unspecified raw materials, rusted and failed. Every shutdown, every failure destroyed the complex mechanisms that had taken decades and billions of dollars to build. And here we come to the main conclusion. The story of Venezuela is not just about politics. It's a harsh parable about how nature's greatest gift can become a trap. Those 300 billion barrels haven't disappeared. They still lie underground. But today, after collapse of infrastructure, they have become even more inaccessible than they were 100 years ago. Restarting this gigantic machine will no longer require simply lifting sanctions. It will require colossal investments, comparable to the cost of oil itself, and years, if not decades, of painstaking engineering. This is an extreme example of how national wealth can become the cause of national paralysis. A warning that in the modern world, geology and physics can prove far more ruthless forces than any economics. Because the wealth lying beneath your feet guarantees absolutely nothing if you are physically unable to lift it. A bent cable